Hello, Shri Harsha. Am I audible?
Yes, ma'am, you're audible.
Okay, welcome to the class. Let's wait for 2-3 minutes for the other students to join. Then I'll start.
Okay, ma'am.
Yes, Shri Harsha. Any problems so far in any of the question? I gave some questions in the homework.
No, ma'am.
So have you done all the questions?
Yes, ma'am.
Okay. Okay, I think we should start. Actually, today I want to give you a revision of the chapter, right? Again, we are going to look at some of the different type of questions. Uh, Okay, so in this question, like in the exercises you have already done, and we have also done the third exercise, which actually is not coming in your exam, but we have done it, right? So you know
Yes,
how
ma'am.
to divide polynomials now. Anyway, now according from your examination point of view, right? And yeah, so different types of questions can be asked from this chapter, right? Like if I consider only first like two exercises only and I skip the third and fourth. So from the two exercises itself, different types of questions can come actually from your second exercise, because first one is the graphical one. So exercise 2.2 can be asked in different way. Like the first type of questions which can be asked are the simple one, right? Where you need to verify. I mean, you can just note down one or two questions of each type so that you can have an idea when you sit and revise the chapter, right?
Okay, ma'am.
Okay, so the first type of question will be of this kind, like verify the relationship between zeros and coefficients. Right. So in this, like this type of questions can be asked. For example, I give you one question like -6 plus 2x square and minus x. So you have done it, right? Now quickly solve it and send me the picture.
Okay, ma'am.
Yes, have you done, Shreyarsha?
Yes, ma'am. I'm sending the picture.
Okay. Yes, I've got the picture. Yes, it's fine, right?
Okay, ma'am.
Okay. So the first type, you have already done. And mainly this question is going to come in your 1 mark, right? So this type of question will be a 1 marker. Or sometimes if some extra condition is given, it can be 1 mark or 2 mark, not more than this, right? Okay.
Okay, ma'am.
Now, second type of question which will come from this chapter, from this exercise is like that, where the sum of zeros and product of zeros will be given to you. Find the polynomial. Okay.
Okay, ma'am.
So if only this much is asked, so it will be asked in 1 mark. Okay. And if he adds something, for example, hence find the zeros, like after finding the polynomial, you have to solve it to find its zeros also. So hence find zeros. So it can be converted into a 2 mark question in that case. Fine. So 1 or 2 mark question. Okay.
Okay, ma'am.
Now this type of question you have also done. Let me just show you one example of the question. So basically this second question of your exercise, right?
Yes, ma'am.
Okay. And now here again, I want to make one thing. I want to discuss something again. Let me give you some examples for that. Just a minute.
Ma'am, can such a question be given for a cubic polynomial?
Actually, the cubic one is out of syllabus now.
Okay, ma'am.
It will not come in your exam. Quadratic polynomial will come because exercise 2.3 and 2.4 are omitted in the new syllabus. We
Okay,
can
ma'am.
practice it at some point of time, but I think it's not going to come in your exam, right?
Okay, ma'am.
Okay. Now, again, I want to say something. For example, uh, like you solve this question, right? And we solve it like this, that, for example, the first one. So sum, that means your alpha plus beta is already given, which is 1/4, right? And alpha into beta, that means the product is -1. And the required polynomial, we write like this. So x square minus alpha plus beta, that is your 1/4x, and plus alpha beta. So that means -1, right? Equal to 0.
Yes, ma'am.
This is, I mean, this is how we did it. But we have not written that k here. So I just want to discuss that again. Okay. So just leave it. Let's take some different example. Let me give you some polynomials. Let's say x square minus 3x plus 2. Fine. The first one. Then the second one I'm giving you.
Ma'am, the way you told was alpha plus beta was 0, so minus b by a is 0, and a would be k, like that. Ma'am, you didn't
No,
use
that was
this.
the, yeah, that was the derivation, right? Just a
Yes,
minute.
ma'am.
That is why I'm again coming to that topic. I just want to make that confusion clear. Okay. So that is why
Okay.
I'm again discussing it. All right. Yeah, the which you are saying, actually that was the derivation from where we get this relationship that alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Yeah, just give me 1 minute. Oh, yes. Okay, then the third example I'm giving you is this. For example, this one, 3x square minus 9x plus 6, right? Even more we can take fourth. For example, 5x square minus 15x plus 10 is equal to 0. Now you look at these questions. Let us try to find the 0 of the first one. Yes, Shirasha, can you hear me?
Yes, ma'am, I can.
Okay, now look at the first one. So this is x square minus 3x and plus 2. So to find the 0, we equate it to 0, right? So I'm
Yes.
just not writing, I'm just trying to solve it. Okay, now we can split the middle term. So 2x and x we can use. So x square minus 2x minus x plus 2 is equal to 0, right? Now x common, then x minus 2 and x minus 2 is equal to 0. Then we have x minus 2 into x minus 1 is equal to 0. So we have got the two zeros are x is equal to 2 and x is equal to 1, right?
Yes.
Okay, now look at the second polynomial. For example, this 2x square minus 6x plus 4 is equal to 0. So in this case, you can see, you can directly use the splitting of the middle term, but I can see there's a 2 common in all the terms, isn't it?
Yes.
Okay, now okay, so you can take this 2 outside and you will be left with x square minus 3x and plus 2 is equal to 0, which is the same polynomial as the first one, isn't it?
Yes, ma'am.
Okay, so if and then in the next step, you can bring this 2 in the denominator. It will just go away and it will convert into x square minus 3x plus 2 is equal to 0. So that means this polynomial will also have the same roots, same zeros, right?
Yeah.
Similarly, if you look at the third one, so here you can, sorry, I just missed the x. So you can take the 3 common. So you will be left with x square minus 3x plus 2 again. Then you can bring this 3 to 0. So that is that means the presence of this number 2, 3 or 5 outside. In this case, you can see you can take a 5 common and then x square minus 3x and plus 2. Same polynomial, right?
Yes, ma'am.
So whether you have a 2 outside, whether you have a 3, whether you have a 5 or some other number, you are getting the same roots. So that means this representation where we say that any general quadratic polynomial can be expressed as x square minus of alpha plus beta into x plus alpha beta is equal to 0. That's how we do the questions, right? So this is
Yes.
incomplete. This is correct, but this is incomplete representation. There has to be k which is multiplied here. All right.
Okay, ma'am.
Okay, so that's k is important because like in this particular case you can see there are many polynomials which are having the same zeros, isn't it?
Yes, ma'am.
Okay, so this k is important. So from now onwards, whenever we will do the question, we will use this representation only, and in the last step we can write that k is 4k is equal to 1. This is the required polynomial. Okay.
Okay, ma'am.
So actually we can have more than one, and I think we should write it properly. So instead of writing only one, we will say that all the other polynomials are going to be the multiple of this particular
Ma'am, so
polynomial.
K can be any number, right?
Yes, k can be any real number, in fact, not only natural, right? This is also important that k is any real number.
Okay, ma'am.
A real number means it can be an irrational number also. I can multiply this by under root 2, doesn't matter. It will go in the denominator and it will become 0, isn't it?
Yes.
I can multiply it by a fraction, doesn't matter. So k can be any real number. It can be natural, whole, integer, or any irrational number. Fine.
Yes, ma'am.
Okay. So to attempt this type of questions, we have to use this representation. Now students are coming so late. Yes, Abdullah, can you hear me?
Yes, ma'am.
Abdullah, you are late in the class and you were also not there in the last class.
Yes, ma'am. Ma'am, I thought that there was only one permanent ID, but it was changing. So I was just waiting for the host to start the meeting.
Oh, what is happening here? Just a minute. Okay. So Abdullah, see, you have a class on Tuesday, Thursday, and Saturday, TTS. Okay, please note it down. 6:30 TTS. You have to join. And if there is any problem in joining, you can just call or you can send a message, right? So don't miss your classes because it's you will not be able to understand in the next class and you will have problem then. Hamna, you are also late today. Yes, Hamna. Okay, she cannot hear me, I think. So Abdullah, we are actually doing a revision of the chapter. How much you have done exercise 2.2 with us, right?
Yes, ma'am.
Okay, so exercise 2.3 is actually omitted in the syllabus. And today I'm giving a revision of exercise 2.2 only. And I'm just saying that how many different types of questions can come from that exercise. So you can quickly take a picture right now and I'll move forward. So this is the first kind of question that can come, okay? Because you have missed it, just take a screenshot. So the question will be of this type, that verify the relationship between zeros and coefficients. So this type of question you have already done. This is the question number 1 of exercise 2.2. All right.
Yes, ma'am.
Okay. Here's my pen. Okay, it's here. So basically this is your question number 1 of exercise 2.2. So this kind of questions will come from this and it will be 1 mark or 2 mark question. All right. Then the second type of question that will come is actually the second question of the exercise, question number 2, right? This. So this type of questions will come from this exercise. Now I just want to, so have you heard this discussion about K or should I do it again?
No, I have.
Okay, you have heard. All right. Next come to third type of question which can be asked from this exercise. Third type. Now in the third type of questions, you will be given, okay, let me give you some examples. For example, if alpha and beta are the zeros of a quadratic polynomial, you please note this down, all of you. And any polynomial is given, let's say px, which is given to be x square. I'm taking a simple one, minus 4x plus 3. All right. Now for this particular polynomial, you have to find the values of, find the value of, okay, now the first one. First, you have to find the value of alpha square plus beta square. So this type of question can also come. All right.
Yes, ma'am.
Okay. Now in this exercise, now how to solve this question. See, this is the only thing you have learned in this exercise. So you have learned the relationship that is alpha plus beta is equal to minus b by a, right? And alpha into beta is equal to c by a. All right.
Yes, ma'am.
Okay. And also you have learned that any general quadratic polynomial is expressed as this: x square minus alpha plus beta into x and plus alpha beta, nothing else. So all the questions will depend only upon these conditions only. You don't have to think anything else. Okay.
Okay.
So just don't confuse yourself. Just think this only, and then you will be able to solve the questions. Okay, Shri Harsha.
Okay,
Now,
ma'am.
now how to do this one? Okay, so from where you will start this? Now what can we do? We only know this thing. We can find alpha plus beta. We can find alpha beta. Okay, then let's do it. So for the solution, for this particular px, which is given, that is your x square minus 4x and plus 3. All right, what is a, what is b, what is c? You note it down first of all. A is equal to 1, then b is equal to how much? Minus 4, and c is equal to 3. Clear? Okay. Now you can find alpha plus beta. So alpha plus beta is equal to how much? Minus of b by a. Yes? Okay. So
Yes.
this will be equal to, Abdullah, tell me how much? Yes, you can see here b is minus 4, a is 1. So how much is minus b by a?
Minus 4 by 1. Minus
Here
4.
again you are making mistake, Abdullah. See, this minus sign is very crucial. Don't make mistake. This minus sign will remain here. Fine.
Yes.
Okay. Okay, you write it like this. I mean, you have a minus sign, this will come here. Okay, it will not go anywhere. Now put a bracket and then put the value of b, whether it is positive or whether it is negative. Okay, so in this case, you have a minus of 4 as your value of b. Clear?
Okay, ma'am.
Understood? So never
Yes.
write directly minus 4 because you have an additional minus sign. So always put a bracket and then put the value of b, whether it is a positive value, whether it is a negative value. You will not write directly. Clear? Understood?
Yes, ma'am.
Otherwise, you will make mistake and the whole question will get wrong. Okay, and a is 1. Okay, now your minus minus will become plus. So you have 4 as alpha plus beta. Clear? Not minus 4. Okay, then next you can find alpha beta. Alpha beta is c by a. So this is simple, 3 by 1, which is equal to 3. So you have alpha plus beta and alpha beta. But you want to find the value of alpha square plus beta square. Now from where this will come? Here you will have to make use of the identities which you have learned in your previous classes. Clear?
Yes.
Okay, let's see. Now from where we can get alpha plus beta square. Now look at this identity. You know, okay, I'm doing it separately here. A plus b whole square. How much is this equal to? Yes, Hamna, can you hear me? Okay, she's having some issues with her audio, I think. Okay, so this is equal to a square plus b square and
Plus.
plus 2ab, right? Okay,
Yes.
so
Yes.
from here I can get the value of a square plus b square, isn't it?
Yes, ma'am.
Fine. So if I do the same thing here, I do my alpha plus beta whole square is equal to alpha square plus beta square plus
Plus
2,
2.
sorry, plus 2 alpha beta. Okay, so I want to find the value of alpha square plus beta square. So I'll keep this on one side. So alpha plus beta whole square minus, so take this 2 alpha beta here, and here you will be left with alpha square plus beta square. Clear? Now
Yes.
you know the value of alpha plus beta and you know the value of alpha beta, so just put it here. So alpha plus beta is 4. So that means 4 square minus 2. Alpha into beta is 3. So this is equal to alpha square plus beta square. And this is 16. And minus 2 into 3 is 6. And this is equal to alpha square plus beta square. And then 16 minus 6 is 10. Alpha square plus beta square. So you have got the value of alpha square plus beta square. So this type of questions can also come.
Ma'am, here alpha and beta are the zeros, right?
Yes, they are the zeros.
Ma'am, so can we find the zeros from the polynomial itself?
Because you have not, no, that way you don't have to do it. You can use that thing to check whether you have done it correctly or not. Like from the polynomial, if you see that, okay, how you are saying, okay, by splitting the middle term, you are saying, right?
Yes, ma'am.
But that we can use to check our result. For example, we have this x square minus 4x plus 3, right? Split the middle term. What will you get? X square minus 3x minus x plus 3, and x minus 3, then minus 1, and x minus 3 is equal to 0. Sorry, equal to 0 because I'm finding zeros. And then x minus 3 into x minus 1 is equal to 0. Okay, so I get the value x is equal to 3 and x is equal to 1. Clear?
Yes, ma'am.
So these are my two zeros, 3 and 1. So if I do alpha square plus beta square from here, so I'll get phi square plus 1 square, which is equal to 10. I mean 9 plus 1 is equal to 10. So I have checked it because it will come as a 3-mark question. Okay, Shri Harsha.
Okay, ma'am.
So that is why you will not do it like this, because to find the zero always come as a 1-mark question. So you have to make use of the identities and then do it, because I mean they want you to do it like that. Okay.
Okay, ma'am.
And then you can do a check if you wish. Okay. Next, the second part of this, which you will help me how to do it. Now for the same polynomial, can you
Ma'am,
just,
can you scroll a bit up?
yes,
I'm just
sure,
writing it down.
sure. Okay, just note it, then I'll give you the second part. Hamna, if you can hear me, can you please type something in the chat box? Or send me on my number something so that I can know you can hear me.
Done, ma'am.
Okay, Abdullah, done? Okay, she can hear me. Yes, Abdullah, done? Abdullah, I can't hear you.
Yes, ma'am.
Done? Have you done?
Yes, ma'am.
Okay. Now second. For the same polynomial, you have to find the value of alpha square minus beta square. Now who will tell me how can I find it?
Ma'am, a minus b the whole square.
A minus b whole square? No, because, okay, if I do this, see, alpha minus beta whole square. Clear? So I'll get alpha square plus beta square and minus of 2 alpha beta. But I want to get alpha square minus beta square. So this minus sign I'm not getting here. What can I do? Any idea, anyone?
Ma'am, alpha plus beta into alpha minus beta.
Yes, that I think alpha plus beta into alpha minus beta. But you want to, but you don't have the value of alpha minus beta in that case. Okay, like, okay, fine. Like she's saying that I can write this alpha square minus beta square as alpha plus beta into alpha minus beta, right?
Yes, ma'am.
Okay. So Abdullah, like I have the value of alpha plus beta. Okay, but I don't have the value of alpha minus beta. So first of all, I will need to find the value of alpha minus beta and then I'll put it here. Okay.
Okay. Okay, ma'am.
Okay.
Okay.
Now, how will I find the value of alpha minus beta? If I do, okay, that I can do like this. If I make use of two identities, for example, I do alpha plus beta whole square. Okay. And then just a minute. If I do alpha plus beta whole square and minus alpha minus beta whole square, if I solve this, no. Okay, let's solve it. Okay, so this will be equal to alpha square plus beta square plus 2 alpha beta, right? And then
Yes.
minus, so alpha square plus beta square and minus 2 alpha beta. Clear? Yes, Abdullah?
Yes.
Okay, so let's open my bracket here. So this will become alpha square plus beta square and plus 2 alpha beta, and signs will get changed. So this will be minus alpha square minus beta square and plus 2 alpha beta. Clear? So this alpha square cancel because one positive, one negative. Similarly, this will get cancelled and you will get 4 alpha beta on the right hand side. Clear?
Yes, ma'am.
Yes, ma'am.
Now look at your LHS here. So what I'm doing is I'm taking alpha minus beta term on the one side and all the other terms on the other side. So if I take alpha plus beta whole square and I bring this 4 alpha beta here and this alpha minus beta whole square I'm taking other side because it is minus, it will become positive. Is this clear?
Yes, ma'am.
Okay. And then if I take the square root of the left hand side, so I'll get my alpha minus beta. Understood?
Yes.
Yes,
So,
ma'am.
okay. So this is alpha plus beta whole square and minus 4 alpha beta. And all these values you already know. You know what is alpha plus beta, you know what is alpha beta. So just put the values. So that means square root of what is alpha plus beta? Please tell me how much?
4, ma'am.
4. Okay. So this is 4 square and minus 4 into how much?
3, ma'am.
3. Okay. So this will be equal to your alpha minus beta. So just solve it. So this is square root of 16 and minus 4 into 3 is 12.
12.
Yes. So this is
2,
square root
ma'am.
of 4 and this will come out 2. So 2 is equal to alpha minus beta. Okay, please note down here. Do this. So alpha minus beta is 2. So now you put this value here in this equation, right? So your alpha square minus beta square will be alpha plus beta is I think 4 and alpha minus beta you have calculated 2. So alpha square minus beta square is equal to 8. Clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, can we do this with any other identity?
Yes, but I think only this identity can be used here. Oh yeah, if you can find some other identity, okay, that's okay. Okay, which you want to do?
No, ma'am, I don't know. I'm asking you.
Oh yeah, actually, sometimes you can start from here also. Let me give you some example. For example, you have alpha minus beta. I mean, you want to find the value of alpha minus beta, right? So you do what? You make a square of this and then you put an under root. Okay.
Okay, ma'am.
Then actually this is the same thing. You will arrive at the same result. I'm just okay, I'm doing the alternate way, no problem. So expand it. So alpha square plus beta square and a minus 2 alpha beta. Okay.
Okay.
Now, yeah, you can do one thing here. If you have already solved the value of alpha square plus beta square, right?
Yes.
See, because the question, if the question directly comes alpha square minus beta square, so obviously you have not done the first part, right? But that part you will have to do now to find the value of alpha square plus beta square, or you do it like this: you add one see alpha square plus beta square, you add 1 2 alpha beta, and then you subtract 1 2 alpha beta, no problem. And then 1 2 alpha beta is already there. Understood? We can add and subtract the same number, no problem. So we have added 1 alpha beta and we have subtracted 1 2 alpha beta. Any problem here?
No,
No.
ma'am.
No,
So
ma'am.
now these three terms will become whole square. So this will become
Ma'am, but
what?
alpha plus beta under root would be alpha plus beta only, no?
Just a minute. Minus 4 alpha beta. Like what you're saying, Harsha? Say again.
Ma'am, if we just take the root of alpha and beta,
Hmm.
the square would go, right?
No, square will go in this. This is individually alpha square plus beta square, then square root of whole. This will not go away. If this was like this, alpha plus beta whole square and then square root, then this square will go away.
Okay, ma'am.
Yes?
Yes.
Okay. So individually it will not go away. Now see, you have arrived at the same result. This is the same step, isn't it?
Yes, ma'am.
So this is also the same step. So here now put the value of alpha plus beta and alpha beta. So it doesn't matter from where you are starting. So you can start as the way I have started, or you can start from this step. So you will arrive at the same result. Okay.
Okay, ma'am.
Okay. One more I'm giving you. Now you will do it.
Ma'am, can you scroll a bit up?
Sure. Okay. Now, ma'am, can you explain third of question number 1 in exercise 2.2? Third of question number 1. Okay, let me open.
Ma'am, completed.
Okay, completed. 6x square minus 3 minus 7x. Yeah, just a minute. Yeah, Hamna has a little query. Let me just do it quickly. Yes, Hamna, so you are not able to solve this one, right? 6x square and minus 3 minus 7x. Okay, so first is to arrange it into the descending power of x, as I told you. So do it like this: 6x square minus 7x minus 3. Okay, now we do the splitting of the middle term. So this 6 into 3 is how much? 18. Do the factors of 18. So 2 into 9 and then 3 and 3, right? Now you have to make combination so that you can get 7. So it's easy, like 9 and 2 can be used, isn't it? 9 and 2. So you want to get minus of 7, so minus 9 and plus 2 that way. So 6x square, then minus of 9x plus of 2x, and then you have a minus 3. And obviously set it to 0, I'm sorry. To find 0, we always set it to 0. Okay, now from first two terms, you can take 3 into x common. So x minus 3. Okay. And then from here, you can take 2 common. Then x minus 3 is equal to 0. And then x minus 3 from both the terms. And 3x plus 2 is equal to 0. So that is going to give you x is equal to 3 and x is equal to minus of 2 by 3. Hope this is clear. And then you can verify the results. All right, we are doing some question. Now let me give you some. Okay, 2 we have done. Now third, this type of question can also be asked. You can be asked to find the value of alpha to the power 4 for the same polynomial. I'm doing everything. So beta square and plus alpha square and then beta to the power 4. So I'm not changing my polynomial. I'm using the same one. Now, how can I proceed here? Who will tell me? Yes, Abdullah.
Yes,
How should I?
ma'am.
Yes, how should I start? I have to find the value of this thing. Can you see something common here? Can I take something common outside?
It's yeah. And that is x4, x to the power 4.
Yeah, this is actually alpha to the power 4,
Oh,
right? And beta square plus alpha to the square and beta 4. So
Alpha square and beta square common.
yes, there is an alpha square in both the terms. Yes.
yes, ma'am.
And then there is a beta square also. So in the first term, I will be left with alpha square only because two powers I have taken outside. So two powers will remain. And second term, alpha square gone. And then two powers of beta gone. So beta square. Clear?
Yes, ma'am.
Yes.
Okay. Now I can write it as, so alpha square beta square can be written as alpha beta whole square. No problem. Yes, that you have
Yes,
studied
ma'am.
in exponents and powers, right? And alpha square plus beta square. Okay. So alpha beta, how much is the value of alpha beta? 3, I think. Yes. Yes.
Yes,
Yes,
ma'am.
yes, ma'am.
Okay. So it's 3 square. And alpha square plus beta square I've already calculated. How much? It was 10, I think. Yes.
Yes, ma'am.
10. Okay. So this is 9 into 10 and this is equal to 90. So if see, because I've already done the first part, so that is why I know the value of alpha square plus beta square. But if it is asked in the exam, so you will separately find out first of all what is the value of alpha square plus beta square, which you already know how to do it, and then you will use it here. Okay.
Okay,
Yeah.
ma'am.
Okay. So because I'm doing for the same polynomial, so I'm just making use of the previous results, but you will have to solve it again, like separately. Now next I'm giving you fourth one. Tell me how much is alpha to the power 4 and minus beta to the power 4. Who will tell me how to do it? See, this is just identities now, nothing else.
Ma'am, can we do like alpha square bracket
Mm.
square minus beta square square?
Yes, that is the only way of doing it. So Abdullah and Hamna, see, whenever you have even powers, okay, So always try to convert it into the formula of a square minus b square, right? So that you can have a plus b into a minus b, right? Okay. So if you want to make the square, you can write it as alpha square whole square, clear? And this you can write as beta square whole square. Yes, Abdullah?
Yes, ma'am.
Okay. So now this is the formula a square minus b square, which is equal to a plus b into a minus b. So your a is actually alpha square plus beta square, and then alpha square and minus beta square. So see, this question is lengthy because I have already done what is alpha square plus beta square and alpha square minus beta square, but you will have to do it if it is asked like this. So I'm directly putting the results which I have already obtained. How much is alpha plus beta? Oh, sorry, alpha square beta square?
10, ma'am.
This is 10. Okay. And this much? Alpha square minus beta square?
-10.
No, we have just solved it, isn't it? 8, I think. We got 8 as the answer. Yes. Where it has gone? Yeah, look here. Here I have done, isn't it? Second part. Yeah, please look at the second part, which was alpha square plus minus beta square. And I've got the value of 8 as the answer, right?
Yes, ma'am.
Okay, so put it here. So I've got 8 previous results. So 80 is the value. So the first 2, 3 are important, like alpha square plus beta square, alpha square minus beta square, and how much is alpha minus beta. So I think these 3 are important because these will be used for other identities as well. So please like practice well how to calculate alpha square plus beta square, alpha minus beta, and alpha square minus beta square. Understood?
Okay, ma'am.
Okay, because these results will be used in the other parts also. Fifth one I'm giving you. For the same polynomial, now you will tell me how much is the value of alpha cube minus beta cube. Now here you will have to use of the cubic identity. Okay, who will tell me?
Ma'am, a minus b the whole cube.
A minus b whole cube.
Ma'am, alpha minus beta the whole cube.
Okay, yeah, alpha minus beta whole cube. Yes, right. Yes, Abdullah. See, you can see a cube here. So obviously you are going to use the cubic identities, and there are only 2. One is a plus b whole cube, one is a minus b whole cube, isn't it?
Yes.
Okay, so let us revise the identities. So a plus b whole cube is how much? This is equal to a cube plus b cube and plus how much? 3ab
3ab into a plus b.
into a plus b. Yes, Abdullah.
Yes.
Okay. And the other one is a minus b whole cube, which is equal to a cube minus of b cube and minus of 3ab into a minus b. Yes, am I correct?
Yes, ma'am.
Okay, so all the signs are all the signs are minus except this a1, otherwise all minus minus. So I want to get the value of alpha cube minus beta cube, which I can see here. Yes. So that means I have to make use of this identity, not the first one. Clear, Abdullah?
Yes, ma'am.
Okay, so how can I do it? I'll keep these terms on the RHS and I'll bring all the other terms on the LHS. So I can write it as a minus b whole cube and bring all the terms here. So plus 3ab into a minus b, which is equal to a cube minus b cube. So let us just solve the LHS. So a minus b whole cube. So should I expand it or what? Yes, okay.
Now we have the value of a minus b.
Yeah, that also we can do. But see, if the question comes, so again, you will have to find the value of a minus b. So it's better you simplify this identity and then see finally what you want to get. Otherwise, you will also find the value of a minus b, right?
Okay.
Okay. Uh, if I put the, again, if I expand this bracket, so a minus b whole cube is how much? A cube. Am I doing it correct or not? Oh, no, no, no. I can do one thing here. See, I have a minus b in both the terms, right? So I'll take a minus b common. Clear? Okay, it's getting difficult to write. I'm writing it here. I don't know what's happening. Yeah, I'm solving it here. So from the first two terms, I'm taking a minus b common, right? So here I'm left with a minus b whole square and then plus 3ab. Clear? Is equal to a cube minus of b cube. Yes?
Yes,
Okay.
ma'am.
Yes, ma'am.
Okay. So this is a minus b. And then you open this a square plus b square and minus of 2ab. Minus of 2ab. And then you have a plus of 3ab. Okay. So this is a minus b into a square plus b square and then 1 minus and 1 plus, so plus ab. So this is finally a cube minus b cube. So you make use of this result. Now here you already know the value of a minus b, right?
Yeah,
You
okay.
already know the value of a square plus b square, isn't it? And you already know the value of a into b. I mean alpha into beta, just convert it into alpha into beta, right?
Yeah.
Okay.
So I'm just leaving it for you. You solve it. And I'm just giving you two parts in the homework. You will try them and tell me the value in the next class. So please note it down.
Okay.
Next, just try. I mean, give it a try. Otherwise, we will solve it. So 1 upon alpha plus 1 upon beta you have to find. Then you also have to find 1 upon alpha square
Ma'am, in
and
the previous one, we know the value of a square and ab, but what about a minus b?
a minus b we have to find out for this question.
Okay.
Yeah. And then I'm giving you beta upon alpha and plus alpha upon beta. And also one more I'm giving you, ninth one, which is alpha 6 minus beta 6. See, don't get panicked by looking at these questions. You have to make use of the previous results only. These are very simple ones. And just give it a thought. And in case you are able to solve it, you can also send me a picture on my number. I'll just go through it. Okay. Okay. So this is your homework. Then some more revision is required in this exercise. We will do it in the next class now. Okay. Thank you.
Thank you, ma'am.
Okay. Thank you. Take care. Yes. Hello, Tala. Can you hear me?
Yes, ma'am.
Okay. Welcome to the class. So you are in class 10th, right?